I will start blabbing. Good morning, good evening, and good afternoon, depending on where you are in the world. I'm Dave Snelling. I'm joined by Josh Langford. We are co-chairs of the OASIS COEL Technical Committee. We are talking about the classification of everyday living specification, which is just about going through its final public review for becoming an official OASIS standard. And we thought we'd reach out to the community and give you a little bit of an insight into what's going on there. First of all, just a little brief introduction. In the chat, I have listed all the live links that are used in the presentation. Feel free to browse in parallel with the conversation here. First of all, COEL is a business-to-business technology specification that talks about and provides a machine-readable way of describing what we do as humans. Whether we get up in the morning, we take a nap, we prepare food, we sleep. We also do things like drive cars, buy products, talk to friends, all kinds of activities. There are many different ways in which we can gather information about what we do as human beings. What this specification does is provide us a uniform standard way to talk about that behavior in a machine-readable format. The specification is focused on the human being and the individual, and therefore is relevant to any organization that wants to collect or analyze data about individuals. And it is gathering and managing data at an individual level. So it's not necessarily just aggregate data, but it's data about individuals as well. So the question here, we have the opportunity, is what can we do to share information about human behavior, and how is that valuable to the individuals, the organization, and society? We don't have an open standard that describes human behavior that is usable across all these domains. If that's available, then that's the opportunity. The question, of course, is what kind of problem does that give us? We need some way to define a protocol for exchanging this information, as well as the content of that exchange. So we need interfaces for interoperability, as well as a semantic basis to describe human behavior. Of course, with human behavior, we are talking about probably the most personal information you could be talking about, much more so than simple identifying information. And therefore, this approach needs to be designed with privacy by design from the beginning. The solution, of course, is COEL, which is why we're talking today. And that gives us a combination of three elements in the specification that provide an open, audible, and international by design approach to dealing with personal information of this type. So in addition to a protocol and a semantic interface, it also describes the operation of an ecosystem that will allow us to meet these goals. So some of the basic features of the technology are we have a unique extensible data model. It's a taxonomy of human behavior. We think that there are about 7,000 individual behaviors classified today. At the top level, there are 31 clusters of activity. You'll see these in a little more detail later. And where you don't know the detail, you can use a higher level of the taxonomy to describe behavior. It's also very clear in the governance model that we describe what roles different actors play in the ecosystem, and that gives us a framework for support and governance. The data, part of the privacy by design, is pseudo-anonymized from the very beginning, and some members of the ecosystem never have visibility of the individual's identity. All the events are coded in a concept called the atom, which Josh will talk about in a little more detail, that covers any human observable human behavior. By a large extent, we talk about observable behavior rather than feelings, emotions, or thoughts. And therefore, we are talking about something that can be measured and something that can be monitored by the environment or by wearables or individually reported or observed. Each individual behavior forms an independent record. These can be then used as multiple data sources for common insight across multiple applications. So these things can be pulled together. At a technical level, everything is encoded in JSON over an HTTPS for security and transparent access. Also, the whole technology is built around a very lightweight delivery in such a way that IoT sources could be used as well as more complicated devices such as iPhones to capture the information necessary. Okay, I think at that point I hand over to Joss. Just ask me when you want to move the slide on, Joss, and he will now go into a little more overview of the technology in general.
Thank you, Dave, and hello, everybody. So the slide here is both an overview for the topics that I'm just going to cover off in the next 10 minutes or so. It is also the structure of the specification. So it's just a little bit of a guide to how to navigate the specification. Dave's given you a little bit of the introduction already and talked something about the architecture. I'll show you some more about that. We described that right at the beginning. An important section following that is COEL by example, and I'm going to give you 3 example case studies where it's being used at the moment. But in the specification, there is a set of detailed coding for all the actions that an implementer would need to take to encode COEL within their specific application. So that's a very useful resource. The 2 key normative sections within the standard are the COEL model, and that's the hierarchical model that Dave explained, and this atom structure, and then the interfaces. And I'm not going to talk about the interfaces in detail here. They're in the standard, and they are, I think, relatively obvious and straightforward. The last section within the standard, which I'm not going to go into great detail here, but you'll see it coming through in all the examples, is the privacy by design. And that's a lot about the governance and the roles and the splitting of competencies between different actors within the system. And the way that we've written the standard is that's a non-normative section for guidance only. So I'm going to then talk to you now through 3 examples. But before I do that, I'm going to talk about the COEL atom. So this is the event-based coding that we use. And the event-based coding gives us basically what we call microstructured data. So it has the benefits of structured data from a governance perspective, and you know where all the data is and you can find it all. But it has the insight generation capabilities of unstructured data, because every single piece of data within the system looks the same. You can code it into a Hadoop structure. And so you've got this very fluid approach to bringing data in and sorting data. So each of these atoms then has the same structure. At the top, there's the what code, and this is semantic code from the hierarchical taxonomy that Dave's explained, and I'll show you a little bit more later on. Every piece of data within the system is coded with a pseudonymized identifier for the individual. This is great from a privacy and transparency perspective. I know that with a single query, I can retrieve every single bit of data about an individual, and because of the restriction of data types, I can be confident that that's robust. All the data within the system is coded using UTC, and I can code all sorts of information as well as the duration of the event. I can code information about the accuracy of the event and certainty of that event as well. Coding location is more sensitive, and so there's an option to leave this information out. We could use exact coordinates, or we can actually use profane locations. So by that I mean I could code that I was at home or in the office, or I was out of the house. And I might want to, for example, give different permissions to access for that data depending on where I am. So that's a very useful way of coding data, very intuitive for the person's perspective, and very usable in an application sense. We can code information about how the event was observed or recorded. And that's important because very often here we don't care how the data was captured. We're making sure that we are then coding the data in a way that can be easily transferred across different systems. And lastly, we've got a field around consent. So we can record dedicated consent information, but we can also record the consent that applied to every single piece of data within the system. So that's the overall structure, and I'm now going to give you 3 examples about how those atoms are then used within the system. So this is an example about a personal wearable, and you could swap any IoT device into this example. And that's where COEL really gives us some strength, because IoT devices, when they're recording data about people, have this facility where they can self-publish data about someone. So compared to a social media situation where an individual is very often pressing send when they send a tweet and they are making a conscious effort to broadcast information about themselves, we're moving into an era with the Internet of Things where devices around us are going to be doing this all the time. And so our understanding of privacy designs is based on that. So here's an example about a professional wearable. This is a device that's been given to a patient by their healthcare professional. And here, this is a UK example. So we've got the NHS, National Healthcare System. And the role that they are taking on is the role of the operator. And the operator owns the relationship with the individual. And they're the only person within this example here that has the directly identifying information for that individual. So they have the unique privilege and responsibility of being able to link the pseudonymous identifier for the patient with their directly identifying information. And what happens here is that the data from this wearable goes directly to the data engine. And that allows us to send data from multiple sources. It allows us to scale globally very quickly. And it allows, in this example, Fujitsu to do what they are uniquely good at, providing global IT solutions. So this wearable is going to send data directly to their data engine, which is the storage service for all those atoms. Activinsights as a business is the business that provided both that wearable to the healthcare professional and also provides the analytics services. So the two things that Activinsights are uniquely good at are manufacturing professional grade wearables and processing data to link behavioral information to disease states, so rehabilitation efforts, disease recovery, disease prediction, diagnosis, that kind of thing. What happens in this ecosystem is that when the healthcare professional has a conversation with the patient, they make a request via API to Activinsight to analyze data for that patient, and they use the pseudonymized identifier to do that. Activinsights is then able to extract the data that they need. They can start an instance, extract the data they need from Fujitsu, process that data using their IP, send that report to the healthcare professional, and then shut that instance back down. So that we're not having multiple instances all the time, and we know we've got that data held by the data engine. It gives Activinsights, who are a smaller business, the ability to run this very simple, secure service in a scalable way as a small business, and very competitively as well, whilst being able to offer the level of security that the NHS requires. So if we go on to the next example, the last example was a very top-down centric approach. This is an example about another user of the standard, Miko, who provide personal information management systems. So these are apps that sit on the phone that organize data about an individual. And what Miko have done is they've adopted the COEL model as their method for organizing data about people. And Miko work within an organizational framework called My Data. And the model that I put up on the screen here is their model that they can map onto the COEL standard, where they have this generic model of a data source and a data using service and an operator. In their model, the ecosystem or the approach is driven from the person rather than from the top down. So the person is making decisions about where their data is stored. And their concept of the operator, which is entirely analogous to ours, becomes the digital agent for that person. So it's their way of interfacing into the digital world. So these are two organizations here that I've put up that are also using the COEL standard, very similar to the previous example, but driven from the person rather than from the organizational down. The last example is a class of use cases where many organizations are beginning to use the COEL model in isolation. And we're seeing this within the research community, particularly. So this is a visual representation of the hierarchy that Dave mentioned earlier. So this is the what code within the atom, and those at the core there are the 31 clusters. And then we move out to classes, subclasses, and finally elements. And that's the 4-level hierarchy that sits within the current standard. The title here is visualizing everyday living. And what we see is that researchers are using this within the social sciences to be able to generate information about how people live their lives in a way that they can very easily share. Traditionally in ethnography studies, an ethnography is created around a particular topic, and it's very, very difficult to bleed information from that across other studies. So this is an example here about how researchers and other organizations can use the semantic base without necessarily moving into the technical interfaces to code information about people in a way that they can transfer learning across different applications. So what I'd just like to do is just close on a slide to talk about why we're putting this call out now and why we're grateful that you've joined us. So we are looking for new applications and implementations. We're very proud of the work that we've done to get to this first version, and now we want to engage more widely. We encourage you to get involved in the public review and then the call for consent that's coming up over the next 2 months. So please share your thoughts about how and where COEL could be beneficial with us. Please do that within your TCs and also within your colleagues more widely. That's our call to action. And so at this stage, then I'd like to ask for any questions.
This is Carol. I don't have any questions, but I really feel like I understand COEL a whole lot better now. Thank you, guys. I thought it was a great presentation.
Thank you, Carol.
And this is Gail Magnuson. I'm involved with the PIMRIM OASIS effort and am involved also with liaisons with ISO for privacy engineering and other initiatives. And I must admit, I have to turn my head around from thinking about an organization down to the individual, but I think there is some significant interaction that we could have with comparing the two standards and models with the privacy management relationship model. And I don't know whether there's an extension to this information, but it's how to fit this structure into a broader dialogue about privacy by design, privacy engineering, and I think there's a lot of possibilities.
I think you're right. I think there's extension capability built within the specification, particularly of the model itself. And the model itself is independent of the technical protocol elements, so can be picked up and used independently in other contexts whenever talking about human behavior. So yeah, I suspect there's plenty of opportunity for collaboration.
Yeah, just to extend, this is Joss again. So if you just look at the way that we've structured the conformance clauses, there are some different levels of conformance, and as I alluded to on the last slide, one of the levels is just to use the COEL model without any of those without those other elements, and there's a level of conformance there which we found quite attractive to other people that want to pick at the knowledge base without having to rely on the specific technical embodiment that is within the specification.
Well, and certainly in the IoT model, there is a connection between the various domains that are involved in the IoT use case, which is very similar to one of the elements of the PIMRIM. And I would really like to, actually I'm going to be in London on the 30th, and if there is a possibility for us to meet face to face, I'd like to do that.
Yeah, I think we would value that, and we'll do what we can to make sure we meet. We'll pick that up as we leave the call.
Hi, excuse me. It's John Sabo. I'm chairing the Privacy Management Reference Model Technical Committee. Unfortunately, I joined very late and only caught the very tail end of the presentation, so I'll have to review the material and the TC information at OASIS. I had one question, having missed all that, so you don't need to review things, but we've got a consumer-oriented set of services. One of the challenges we've had in data protection, data privacy, has been the ability for consumers to actually manage their relationships with all of the data users, data repositories, domain owners, etc. It becomes a giant stew of data with, for example, the inability to, for a consumer with probably hundreds of online relationships, to understand how they can manage a particular relationship and, for example, withdraw consent. Could you talk, if you have addressed this, that's fine, but from a data protection point of view, you haven't. Can you talk a little bit about the manageability of all of this from the data subject's perspective?
We can do one quick one. One of the, since with the specification is about tracking and recording human behavior, the action of granting, withdrawing, or extending consent is one of the model elements. And so this is one mechanism that you could build a service around that would be able to track and record the consent you granted, to whom you granted it, consent receipts associated with it, and possibly even consider information such as which categories of information have you granted consent for to that individual. It isn't an all singing, all dancing, solve all my multiple external repositories. But if you could build a service around some of the COEL capabilities that would make that process at least an open standard-based approach rather than one of many private attempts to solve the problem. I think you could look at the video, because I think Joss also talked a little bit about My Data Miko exercise as one of the use cases that is addressing part of that challenge.
Yeah, so
okay, thanks. I'll take a look.
Yeah, this is Joss. I mean, I think I agree with the challenge that you articulate within the question. One of the ways that we are trying to move towards some solutions on that is around data portability. So some of the discussions that I've had about the implementation of this specification has been with the personal data store organizations, and giving them the ability to both take in and also return queries in the data format that we've specified here is looking to be quite a promising thing that they want to do. And so almost we end up with using the data type that we specified here as a data transfer format, as a common way of talking, because of its very strong semantic basis. Now we're part of, the work that we've done has been picked up some of the semantic web people within W3C, and so that's quite an interesting development. Specifically in the area of consent, we do cross-reference the Kinsara consent specification work that's been done, and we continue to be active within that area as well to help the addressing of that specific consent question. There is more work that needs to be done, I think, in many areas, but we recognise it's important. I think that we've got a good basis to start on, and we'd be happy to talk you through some more detail in that area, because I do have a consent record case study, which I didn't include here because it's quite specific and narrow, but I can talk you through the detail on that.
Okay, folks.
Thank you.
We're running to our last 2 minutes, and apparently we have a rocket hard stop here. So I want to thank you all for joining, and please take a look at the links that are available. The presentation will be available to you as well, and just spread the news. I think we have something here that should see a little more light of day than it has in the past. We've had a wonderful time putting it together. Let's hope we can all use it. Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you.
Thanks.
Bye now.
Thanks for the presentation.